On to question number 4. A car has mass 1400 kg. When the speed of the car is v meters per second, the magnitude of the resistance to motion is kv squared newtons, where k is a constant. So k being a constant means that whatever the value of v or the resistance to motion, the value of k will remain the same. And in this kv squared, the v means the speed of the car, as mentioned. So part A, they say the car moves at a constant speed of 24 meters per second up a hill inclined at an angle of alpha to the horizontal, where sine alpha is equals to 0.12. At this speed of 24 meters per second, the magnitude of the resistance to motion is 480 newtons. So in part 1, we are to find the value of k. Now k is mentioned over here. Kv square, which is the magnitude of the resistance to motion. So in the A levels mechanics paper, whenever they're talking about resistance to motion, we're always talking about friction. So that means that friction is equals to k times v squared. So in part A, they mentioned that the speed is 24 and the resistance to motion, meaning the friction, is 480 newtons. So that means 480 is equals to k times 24 squared. And when we rearrange this equation, this means that k is equals to 480 divided by 24 squared. So that means the value of k is 5/6. On to part 2, they are asking us to find the power of the car's engine. So we know that the formula for power is the driving force of the car multiplied by the velocity or the speed of the car. So from this equation, we already have v, which is given to us as 24. So this is 24. Now to find out the power of the car, we only need to find out the driving force. Now we can find out the driving force by using the force formula, which is forward force minus resistive force is equals to mass multiplied by the acceleration. So forward force in this case is unknown, and we have one of the resistive forces, which is friction. So this means forward force minus 480, which is the friction. But now we also have to take into account the downward component of the weight of the car, because the car is inclined at an angle of alpha, as mentioned in part A. So for example, this is the hill, this is the angle of alpha, and this is the car. So when we resolve the weight, this angle will also be alpha, and so this will become 14,000 cos alpha, and this will become 14,000 sin alpha. So this is the car which is being moved forward by the driving force and the power of its engine, and this is the friction on the hill, which is moving it backwards. But now we have to also take 14,000 sin alpha, which is the horizontal downward component. That means forward force minus 480 minus 14,000 sin alpha. Now in this question, they've already given us the exact numerical value of sin alpha, which we'll use over here as 0.12 is equals to mass, which is 1400, times the acceleration. They've also mentioned that the car is moving at a constant speed of 24. So when you're talking about constant speed, that means that there is no change in speed, meaning that the acceleration is 0. This makes this whole side equal to 0. So that means that forward force is equals to 480 plus 14,000 times 0.12. this is 2160. So the forward force, also the driving force in this case, will be 2160. So now when we substitute this value of the forward force and this speed of 24, we will get the power of the engine. So power of the engine is equals to 2160 times 24. So 2160 times 24 is 51840 joules. Now moving to part B, they say the car now moves at a constant speed on a straight level road. Given that its engine is working at 54 kilowatts, find this speed. So let's show this information in a diagram. So this is the car and this is the downward component of the weight, which is 14,000, and this is the driving force of the car. So they've given us the power of the engine, which is 54 kilowatts, meaning 54,000. So we know that the power, as per in the last question, is driving force multiplied by the velocity. Now in this case, both the driving force and the speed are missing. So but we can find out the driving force by using the force formula we did in part 2. So again, the acceleration is 0 since the car is moving at a constant speed. So the forward force, which is missing, minus the resistive force. So now we will not use the value of 480 because this was the resistance to motion only when the speed was 24. But now in part B, the car is not on that same hill. Now it's on a straight level road where the speed is not given to us. So now we will use the formula given to us in the introductory paragraph, which is that the friction is always equals to K multiplied by the V square. So that means that the resistive force will be K, which we find out as 5/6, which is a constant. So this will be 5/6 V squared is equals to mass, which was 1400, and the acceleration is now 0, as we found out here. That means that forward force, the driving force, is equals to 5/6 V squared. Now we can use this value of the driving force and substitute it in this formula. So that means that 54,000, which is the power, is equals to the forward force, which is 5/6 V squared multiplied by V. This makes it 54,000 is equals to 5/6 V cube. So when we divide 5/6 on both sides, this means V cube is 64,800, and when we take the cube root of this, we get 40.16. This is the speed of the car. We will round it off to 3 significant figures to 40.2 meters per second. This is the end of question number 4.